So welcome to the class. We are continuing projectile motion. Today we're going to do a topic wherein we'll do you know two angles for which the range of projectile is same. Alright, what to do here. That's our heading. Okay. The range of projectile is same. Alright. Let's start the topic. So you see, let's talk about a projectile motion. Let's try it a little better. This is a projectile. Suppose the projectile is thrown with an angle of theta degrees. Okay, with an initial velocity u. This is your x-axis. This happens to be your y-axis. Okay, that's our this. Now, what was the range of the projectile? See, the range of the projectile came out to be u square, if you remember. It was u square. Okay. U square sine 2 theta divided by g. Okay, the projectile was range equal to u square sine 2 theta projected by divided by g. Now see one thing, we know that sine theta is equal to sine of 180 degrees minus theta. This is a trigonometric identity. Alright, the sine of an angle and sine of 180 degree minus that angle, both the values of sine is same. Now let us look at sine 2 theta. Clear? So we can say that sine 2 theta is equal to sine of pi in radians, 180 degrees written as pi, sine pi minus 2 theta. Okay. If I feel all of you understand this. If you don't understand, you go to send me a message. Okay. And when I say send a message, means you have to send a message. Okay. So sine 2 theta equals sine pi minus 2 theta. This equation we made. This is an made. So for example, suppose we are taking the projection angle. Let us say one projection angle is theta, all right, and another projection angle is so that the angle happens to be pi minus 2 theta. I'll explain you what does it mean. Let us say one of the angle is theta. Okay, one projection angle is, let us say, theta, and let us say another angle is phi. So if one angle is theta, another angle is phi, so that if sine of one is 2 theta, for first projection, what will the range come? Range will come according to sine 2 theta. If sine 2 theta is equal to if this phi is satisfying the condition that 2 theta plus 2 phi equal to 180 degree pi. So we will get 2 phi equal to pi minus 2 theta. You understand? Clear? Pi minus 2 theta will get. So sine 2 phi, see, sine of 2 phi, this will come as nothing but sine of 2 theta. Are you understanding? Sine of 2 phi will come as sine of 2 theta. So for both of them, for both the first range, so the first, both the ranges, you see, the one range will come as, one of the range will come as u square sine 2 theta divided by g, first range, and the second range is going to come as u square sine 2 phi divided by g. But we have already proved that the sine 2 theta is equal to sine 2 phi if 2 theta plus 2 phi equal to pi. So if 2 theta plus 2 pi is equal to pi, if 2 theta plus 2 pi is equal to pi, then both the ranges happen to be same. Are you understanding? So in which two cases will the range be same? Range will be same if 2 theta plus 2 phi equal to 5. Okay. Let us solve this 2 theta plus 2 phi equal to 5 in me. Let's get this. See, if 2 theta plus 2 phi equal to pi, we'll solve this equation. See, if 2 theta plus 2 phi is equal to pi, this means theta plus phi equal to pi by 2. Am I correct? Theta plus phi equal to pi by 2. So, if the two angle of projection, one angle of projection is, let us say, theta, and another angle of projection is, let us say, phi, so that theta plus phi equal to 90 degree, pi by 2. Then what happens? Ranges are same. Understanding? Both the ranges of those projectile will be same. You should understand this, that you see the maxima. See the amazing thing over here. The maxima can happen only when theta plus phi both are equal. Okay. Yeah, the maxima will happen only when theta plus phi both are equal. All right, I'll show you that. So let's rub this off. Yeah, let us rub this off. So I'll just get rid of all this. So what did we learn? We learned that if theta plus phi happens to be 90 degree, ranges is same. Understanding? If theta plus phi happens to be pi by 2, our ranges is same. So we got that. We got if theta plus phi equal to pi by 2, the ranges are same. Okay. Ranges are same. Let's say so theta plus pi equal to pi. What does this mean? Basically, this means what? Angles are complementary, na? If angles are complementary, let us say, for example, I'm going to take two angles. Let us say theta equal to 30 degree, and I will take phi equal to 60 degree. Clear? Let me find the range for 30 degree. So it comes u square sine square 30 u square sine 260. Okay, I get sine 2 into 30. All right, so sine 2 into 30 degrees divided by what we get over here, g. So what does this become? This become u square sine of 60 degree divided by g. This is first range. Let's get the range for the second. For the second, it is u square sine of 2 into 60 degrees. Clear? Now, what is that? That is sine 120. So, I get u square sine of 120 degrees divided by g. And what is sine 120? Somebody know what is sine 120? Actually, I'll tell you, because you just now come to 11th. I don't know whether you know this equation or not. But you know that sine 90 plus theta is what? Cos theta. Okay? You know, this much you know, I know. Sine 90 plus theta, you know that sine 90 plus theta, this equation is equal to cos theta. So can I not say that sine 120 is sine 90 plus 30? And how much is this? Here, this is cos 30. So I can say that sine 120 is cos 30. So u square cos 30 divided by g. But cos 30 and sine 60 both are same, no? Clear? So you see both these ranges are coming equal. You see both the ranges are coming equal. You understand? So get now get the point clear that the range is same for two complementary angles. So if the projectile is thrown with one angle of if the projectile is thrown with one angle of theta and another angle of anything, so that it's complementary. If one angle is theta, other angle is phi, so that theta plus phi is equal to 90, then the ranges are what? Equal. Clear? Okay, so this is half the problem. Now let us move on to the next topic. Okay, let us move on to the next topic now, which is we're going to now study what happens when a body is here. We are projecting the we have solved these projectile motion till now. We have solved when the body was projected from ground. Okay, now let us do one thing. We're going to project the body somewhere from a height, not from ground. We're going to project the body somewhere from a height and not from the ground. I'll explain you what does it. What I mean is, okay, when body is projected from the height rather than from ground. Okay, let's solve this problem. So I want to see so much of me. Let's just reduce it a little bit. Yeah, put it over. Okay, fine. All right. So body is projected from a ground, from a height. So understand what does this mean? What it means is the body is projected from a ground, from a height. So let's say that this is a this became too much. It's a tower. Okay, let's say a body is projected here. Let us say a body is projected from top of a tower All right, this is the tower top. So the body is projected from here with some initial velocity, clear, like this, with some initial velocity. Yeah, let me take a different marker. So with some initial velocity, I'm going to take this velocity. I'm going to take this. This should be horizontal. Okay. So let's have a horizontal velocity. Some horizontal velocity u. So this type of a motion, okay, this type of motion will also happen to be projectile motion. Now let us first understand why is going to be projectile motion. See, the body has some horizontal velocity but zero vertical velocity. Actually, it's like, simply if you imagine, if you had thrown a body from here, body would have traveled like this. Okay, body would have traveled in this path. This would have been the path of the body. This would have been the path of the body, like this. Body would have traveled like that and further continue. We are not throwing the body now from a ground. Instead, we are throwing a body from some. We are throwing the body from some height, from here, somewhere from here. We are throwing the body. So if you're throwing the body from here, you see the body possesses some amount of a horizontal velocity. Body has got some horizontal velocity, but body does not have any vertical velocity. So it moves downward under the acceleration g with zero initial vertical velocity, and the time it takes to fall onto the ground, it will take some time to fall onto the ground. Let us say this height of the tower from where the body is dropped, let us say the tower height is h. Okay, so if the tower height is h, body takes some time to drop down. In that much amount of time, body also moves rightward. Body also moves rightward. Clear? So this motion, subsequent motion, happens to be projectile motion. We are going to solve this equation here. Let us first of all try to find Vt, velocity of the body at any time t. We are very clear velocity of the body. See, the equations are very simple. This is the same equation. V is equal to u plus at. I will not fail to remind you that this type of motion, the motion which we are studying, what is that motion? That motion is constant. That motion is constant acceleration. We are studying this entire chapter with constant acceleration. Our main condition is that a should be constant. This here a is constant, g. Clear? Let's solve this problem. So Vt equal to u plus at. You see, at initial moment, the velocity is completely horizontal only. This is your origin. Velocity is horizontal. So I will say u cos theta, clear, into t. So there is no t, no need to write any t. So v is equal to the original velocity was in I direction, so we have u cos theta I plus acceleration. Now what is the direction of acceleration? Direction of acceleration is downward, so I'll write minus g over here. Okay, minus g, it's in the direction of j. All right, and t, time t. Yeah, time is a scalar. So my Vt, you see Vt comes like this. So Vt, you see, has got two components. This is the x-axis component and this is the y-axis component. Let's look at that. Let me just write it a little more, elaborately. So it is u cos theta, clear, into I plus minus gt into j. This is your velocity at any time t. You can very clearly see that the body has got vertical as well as horizontal velocity. Body has got vertical as well as horizontal velocity, and the horizontal velocity of the body is constant. Horizontal velocity of the body is constant. It is the vertical velocity which is gradually increasing with time downward. It's the vertical velocity which is gradually increasing with time downward. All right. This is the net velocity of the body. Now, let us find out the time in which takes. Let us calculate the displacement st. All right. You remember we are going to simply use the formula. Okay. V equal to u plus at, st equal to ut plus half at square, and we substitute all the three parameters u, a, v in there with their respective with their respective directions. So let's look at this. S is equal to, see, we have ST, the displacement of the body, ST equal to, what is the formula? UT plus half into AT square. Alright, and this A is also, A also happens to be a vector quantity. Yeah, fine. Let's continue. So what is our U? What is our U? Is the initial velocity. So that is nothing but U actually see here cos theta is 0, no? Okay. I'm sorry, I used the word cos theta, but this theta is 0. It's the angle which it makes 0. So this theta is 0. So we can rub off this cos theta. There is no need for this cos theta. There is no need for this cos theta. Similarly, there is no need for this cos theta. Clear? It is finally U only. I'll rub off this cos theta also. Fine. So the displacement ST is given by U into T plus, this is in I direction. This is in the direction of I. There. So UI, clear, plus half into acceleration is minus G into J direction into T square. Alright, this is your ST. So ST comes out to be U I minus half G T square J. Alright, this is your ST. So the displacement of the body at any point of time is given by this equation. Along I it is U, along I it is UI, along J it is minus half GT square. So you see gradually look at this equation, the displacement of the body increases along X. So the body comes from this point, its displacement increases along X. So it moves along X-axis. As time passes, it moves along X-axis. Clear? Second is, as time passes, its displacement along Y decreases. That means it moves against negative Y, towards negative Y. So from here, its displacement moves, gradually increases towards negative Y. So body comes down. So body has downward motion as well as rightward motion, and subsequently this is the path of the body. Clear? This is the path of the body. Clear? So this is an equation for projectile motion. The actual definition, of projectile motion is that the motion with constant acceleration so that the path of the body is a parabola is projectile motion. Since we have not done parabola as of now, so I am not going to that detail. Clear? So you see, this is the this type of equation is a projectile motion. Here, what is the maximum height? The original height itself is the maximum height. What is the range? This is the range. This is the range of the body. We can find out the range by, how to find the range? See, we will find the time it takes for the body to fall. How much time the body takes to fall down. We're going to calculate that by putting downward displacement equal to minus h. Clear? Putting downward displacement equal to, we'll put downward displacement equal to minus h. See, finally, where will the body reach? Body will reach here. Body is going to reach here. So what is the vertical displacement done by the body? Vertical displacement done by the body is minus h. We already know it. Vertical displacement done by the body is minus h. This one. Clear? This minus h is the vertical displacement of the body. So we are clear that vertical displacement. So we can get it at putting by minus half gt square equal to minus h. So now simplify all this. We'll get t value equal to 2g. The t value will happen to be under root. From here you see your minus this minus and minus this minus minus got cancelled, this minus is cancelled, this minus square. You have t value equal to, you see, 2h upon g under the root. Okay, so body takes this much time to fall. This is the time of fall. This is the time of fall. Body takes this much time to fall. Yeah. So time of fall, the time of fall of the body downward is under root 2h by g. Yeah, this. And in that much time, how much the body is going to travel forward? How much the body will travel forward? This range. So how to get this range? Yeah. How to get this range? You see, this range, you see, can be obtained by this time of fall t into u, and cos theta is 0 over here, so just u, all right, so into u, so that is u into under root 2 h divided by g. Clear? So you see, basically body travels this much distance along the horizon. Okay, body travels this much distance across the horizon. You can note it down, then I'll rub it and we'll move forward. Okay. So let me jot down all the results over here. Time of fall, time of fall is given by under root 2h divided by g. Range of the projectile is u into under root 2h divided by g. All right. I hope you understand. Let's move ahead. Let's take a question. Okay. Let's take some problem. One more thing, if theta equal to 90 degrees, look at the gravity projectile. In the gravity projectile, in this projectile, see, in this projectile, the body travels like this, all right? Sorry. The body actually moves on a curve like this. So the gravity is acting downward. There is a u. So the angle between u and the ground is theta. All right. So you can even say the angle between u and the gravity is 90 minus theta. So if this angle, you see, if theta, you see theta equal to 90 degrees, this simply reduces to the vertical motion, which we have done a lot number of times. Okay, and you will see all the equations will reduce exactly for that. Like you see, the maximum height equation was coming as what? U square sine square theta upon 2g. You remember? This was the H max, na? Okay, H max was this. So if you see theta equal to 90 degrees, if theta is 90, what is sine 91? So H max reduces to u square into sine 1 upon 2g. Clear? So this, you see, remember, this was very much the equation when the body was moving in vertical direction. Okay, when the body was moving vertical. So basically, you can in projectile motion, if you put theta equal to 90, it reduces to the vertical motion which we have already done. Okay. Okay. All right. Let's take a question. Imagine this is a tree. Let's make a tree. Right. Let's have a tree. This is a tree. And on top of a tree over here, there is a monkey. Okay. So you got a monkey over here. Looks like a bird, but we can just name is a monkey, and this thing becomes a monkey. Okay. So this monkey wants to jump into this monkey wants to jump into a pool. All right, there is a pool over here. Let's say this is the pool. Okay, the distance of the pool is x from the x meters from the base of the tree. Clear? This tree, let us say, is of height h. So the tree is of height h meters. Clear? So the question is that calculate the speed. Okay, calculate the speed by which the monkey should actually jump horizontally. So basically, question is that you calculate the velocity u, find u, so that the monkey jumps and land exactly at the pool. Okay, monkey lands exactly at the pool. We are going to first solve this problem in the most simple manner. Then we are going to actually make it a little bit complicated. We'll give a width to the pool. Right now we are considering that from hereafter it is pool. Hereafter it is all pool. Okay. So this is what? This is pool. Let's make it pool. Okay. And this is ground. So let's make it the ground with little bit colored. Ground with color. Okay, this is all ground. This is all ground over here. And this is all pool over here. So there's some water splashes which has happened on the ground. Doesn't matter. All right. Yeah. So question is that find the speed of the monkey by which it should take off so that it lands into the pool. Okay. So now you see this is a problem of projectile motion. This is a problem of projectile motion. See the monkey when it starts the jump. Okay. When the monkey starts the jump, at that point of time, he will land into the pool. So you see the motion of the monkey is from a certain height, and the velocity is horizontal, and it is taken downward because of the gravity. So this is basically a case of projectile motion, and we want that the monkey should travel minimum x meters horizontally in the time it falls by a height of h. So you see one thing, let us say, see the time of fall, all right, time of fall of h meters, you know, the time of fall of h meters is how much? We have just done that. That is 2h upon g. Clear? The time of fall of h meters is root 2h by g. So in that much time, monkey should travel. Monkey should minimum travel x meters horizontal. Why I am using the word minimum? You see, our objective is to make the monkey. We want the monkey to reach here. That's all. The monkey to reach here. Now, monkey to reach here. Whether it reach here or here or here or anywhere beyond this point, if the monkey lands beyond this point, he's safe. He's in the pool. He should not fall in the ground. That's our objective. So he should minimum travel x. If it travels more than x, no problem. Okay. So monkey should travel minimum x meters horizontal. Okay. Monkey should travel minimum x meters horizontally. So let us calculate the horizontal displacement. You see, the horizontal displacement is u into the time of flight, that is 2h divided by g. Clear? This should be minimum x. Clear? So that means u equal to what? X upon under root 2h divided by g, and this comes out to be x root g divided by 2h under root. Yeah, this much meters per second. This is the minimum velocity. Minimum velocity required for the monkey. See the time. You see, the time of fall. This time of fall by which it falls the distance h. It is independent of the velocity by which it takes off. Whether it shoots rightward with 0 speed, or with 10 meter per second, or with 20 meter per second, the time it takes to fall downward distance of h, it is independent of its horizontal speed whatsoever. Clear? So here, what is the minimum speed by which the monkey should start? That is x under root g by 2 under root 2h. Okay, are you clear with this? So let's stop this video and see how much has it come nicely. I hope it should have come nicely. Okay, so we'll meet in the next video. Thank you.